Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Irfan Rushadi bin Muhammad Nazri, matrix number 2021480544. So today we will discuss about experiment 2, which is input or output programming using assembly language. The objective of this experiment is upon completion of this laboratory session, the student will be able to program STM32F446RE microcontroller using assembly language. So this experiment uh, divided by two parts. The part one is output. So the first question: set connection of LEDs in the breadboard as shown in Figure 2. Then write a program using STM32F446RE microcontroller assembly language that will turn on LEDs D1, D2, and D3, and then turn off those LEDs. Load the program to the microcontroller and explain the finding in the report. So this is the coding here for part 1. And to enable this part 1, we use port B, which is PB4, PB5, PBX, and PB9. So to enable the port B, at RCC underscore AHB1ENR, we put 1 at GPIOB, and the rest is 0. So we will get 2. So for the coding, we put 2 here. And the memory address for the RCC ASB1ENR is 0x400-23830, and we will put it here. So next is GPIOB model. So for the GPIOB model, we use it to enable the PB4, PB5, PB8, and PB9. And the memory address is 0x400-20400. So here, to enable the PB4, PB5, PB8, and PB9, we because this is we GPIOB model is divided to first BIC and ORR. For the BIC, we put 11 at model 4, 11 at 5, 11 at 8, 11 at 9, and the rest is 0. So we use the group of 4, and we will get 0, 0, 0, F0, F00. So the BIC address is equal to 0x00F0F00, and the ORR, which is we want the LED to turn on. We put 01 at 4, 01 at 5, 01 at 8, and 01 at 9. So we will get 0005050. So the address for ORR is 0x00050500. So for the coding, here GPIOB model, this is the memory address, and the value of BIC we will put here, and the value of ORR we will put here. Next is we for the LED to turn off, to turn on, there will be condition. So we will use GPIOB underscore ODR. So this is the value 0x400-20414. So for the GPIOB underscore ODR, condition 1, it need the question 1, LED1, LED2, and LED3 to turn on. So we will put the because this is active low, we must put the logic 0 at LED1, LED2, and LED3, and the rest we will put the logic value of 1. So we will get F, E, C, F. So the condition 1 address is 0x0000 FECF. And for the condition 2, it says that we need to turn off the LED1, LED2, and LED3. So we put the value of 1 at 4, 5, 8, 9. So we will get F, 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 F. So the condition to address is 0x0000 F, 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 F. Let's look at the coding. So this is the GPIOP ODR. So the value of to turn on the LED1, LED2, and LED3, the value of condition 1, which is 0 at 00000 FECF, we will put in the coding here. And the condition 2, to turn off LED1, LED2, and LED3, we get here 0x000FFFF, and we will put it in the coding. Same like here. So for the question 3, the question need us to modify the program so that LED will turn on one by one, starting from LED 1 until LED 4. So this is the coding. We use the same port B and the same BB4, BB5, BB8, and BB9. So it is the same as the part uh, part 1A. So the difference is the GPIOB ODR. So we will so the question need us to turn on one by one LED 1 until LED 4. So this is the memory address of GPIOB ODR. So condition 1, it needs us to turn on LED 1. So LED 1 is at 4. So we will, because this is active low, we will put logic 0 here, and the rest will be 1. So we get F, 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 E, F. So the condition 1 address is 0x0000 FFDF. For the condition 2, we need to turn on LED 2, and because it is active low, we'll put value 0 at 5, and we will get the rest is we put 1. So the rest is F, F, D, F. So the address for condition 2, 0x0000 FFDF. And for the condition 3, we turn on LED 3, so we will put 0 at 8, and the rest will be 1. So F, E, F, F. The condition 3 address is 0x0000 FE, FF. For the condition 4, we will turn on LED 4, and it is active low, so we will put logic 0 at 9, and the rest is 1. So we get FD, FF. The condition for address is 0x0000 FD, FF. So uh, from we get here, this is the condition 1, which is 0x0000 FFDF, and condition 2, 0x000 FFDF. Same like here. And for the condition 3, which is the LED tree will turn on, and the value is 0x0000 FEFF. 0x0000 FEFF. And the condition 4 is 0x0000 FDFF. 0x000 FDFF. So we will go to see the LED at the breadboard.
Okay, Assalamualaikum and good evening. Today I will present to you about the part 2 of the lab 2. So the question here says construct the connection of push button and LED on the breadboard as shown in figure 3 here, like here. And write a program. And then when the S1 being pressed, LED D1, D2 and D3 will blink. When the S2 being pressed, LED D1 until D4 will turn on one by one. And when no push button we press, all LED will off. Okay, so as you can see here, it is active low here. Okay, let's go to the paperwork. Okay, first we set the RCC AHB1ENR GPIOA and GPIOB, port A and port B, port A as the input and port B as the output. And then we set the GPIOB model, port B, enable the port output 4, 5, A, 8 and 9 to turn on the pin. And then this is like the question number 1 here. We got like question number 1. BIC 0x00F 0F00 and ORR 0x000F0F00. Same just like the previous question. And then we set the for the input here we need to do the paperwork table GPIOA model. For switch A1 and A4, we use two switch. And then the BIC that we got here is 030C. 0x000030C. Okay. And then, before we proceed, we need to do the masking first. Because we only do masking for the input. As you can see, we use two switch. And then we need to enable the switch at port A1 and port A4 here. They put logic 1 here. And then it becomes 0 at 0000012. Okay. For the condition 1 here, as you can see, when S1 close, be pressed, and S2 open, we put the logic 0 here, that the S1 after be pressed, and 1 here for the logic 1 here for A4, switch A4, BS and BR here. Okay, and then for the output, we use the condition for the condition 1 here, we need to on the LED 1, 2 and 3. Means like 4, 5 and 8. And then we need to enable like this. We put the logic 000 at 4, 5 and 8. And then it will become 0 at 000 FECF. To turn off the LED, we need to put the logic 1 here at the bottom of the here, BS, and become 0000 FFFF. Okay, let's go to the coding. Okay, as you can see here, this is the RCC AHB1ENR. We enable the port here for the I mean we set RCC AHB1ENR, and then we declare GPIO A model for the input port A, GPIO B model for the port B, and then GPIOA IDR for the input, and GPIOB ODR for the output. And then this we use RCC HB1ENR, and then to enable the port A, and then we use RCC HB1ER to enable the port B, and then we use the GPIOA to enable the pin for the port A, and GPIOB to enable the pin at the port B. This is uh, the binary that we got from the paperwork. Okay, for the switch one, we first we switch one here is you go to the GPIO A IDR for the input here, port A. We used to do the masking first. We used to do masking first at RC here, 0 at 0 0 0 0 1 2, and then we use the masking, and then we make the condition one here, 0 at 0 0 0 0 1 0, just like the paperwork. And then if switch one is pressed, and then we go here, we just go here, yeah, we go here, equation equal to leader on here. For the output, GPIB port B output, we use just like the paperwork, 0 at 0 0 0 FECF to turn on the LED 1 2 3 4 5 and 8, and then to turn off the LED, like the blinking, use the just like the paperwork, binary 0 at 0 0 0 0 F F F F. Okay, that's all for the condition one. And here, this is the simulation. Okay, for condition S1, okay, so here's the simulation. Okay, so for the condition number 2, I will pass to Anwari for the next. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Anwar Azri bin Kamaluddin. Saya akan menerangkan tentang lab 2 part 2, condition 2, when the S2 being pressed, LED D1 until D4 turns on one by one. Sebelum tu kita kena tengok dulu sama ada input dia ni active high atau active low. Untuk tentukan dia sama ada active high atau active low, kita tengok pada dia punya supply, resistor, push button dan juga ground. Apabila push button berada di bawah resistor, berhampiran dengan ground dan berjauhan dengan supply, kita boleh simpulkan input ini adalah active low. Untuk output pula, kita boleh lihat di sini tiada ground, jadi output ni juga adalah active low. Okay, maka kita kena letakkan logik kosong pada PB4, PB5, PB8 dan PB9. Sebelum kita buat GPIO IDR, kita kena buat masking dulu. Masking hanya dilakukan pada input sahaja. So, kita menggunakan input PA1 dan PA4. Jadi kita perlu letakkan logik 1 dan logik 1 pada pin 1 dan logik 1 pada PA4 pada GPIOA IDR. Jadi value GPIOA IDR masking kita adalah 0x 0000 0012. Next, untuk turn on kan S2 ataupun apabila S2 is pressed, itu adalah condition 2. Jadi apabila condition 2, S1 akan open dan S2 akan close. Jadi disebabkan kita punya input adalah active low, jadi kita kena letakkan logik kosong pada pin 4 dan logik 1 pada pin 1. Dan kita akan letakkan logik kosong pada pin-pin yang lain. Jadi nilai untuk GPIO A IDR untuk condition 2 kita adalah 0x 00 00 00 02. Lihat pada coding yang telah disediakan. Untuk membuat untuk melakukan execute S2 untuk turn on, kita kena comparekan R5 dengan GPIOA IDR condition 2, which is 0x 00 00 00 02. Bila sama maka LED on 2, jadi kita akan jump ke coding LED on 2 dan coding akan execute pada coding LED on 2 sahaja. Pada LED on 2 kita dapat lihat kita punya condition adalah turn on one by one. Jadi apabila D1 turn on, D2, D3 dan D4 akan turn off. So kita akan, jadi ada 4 condition. Apabila D1 on, ke D2, D3, D4 akan turn off. Maka kita akan menggunakan table ni sekali lagi. Untuk output, ia juga adalah active low, jadi kita akan letakkan logik kosong pada pin 4 kerana D1 berada pada pin 4, D2 berada pada pin 5, D3 berada pin 8 dan D4 berada pada pin 9. Jadi untuk D1 on, maka kita akan letakkan logik kosong pada pin 4 dan logik 1 pada pin 5, logik 1 pada pin 8 dan logik 1 pada pin 9. Kita juga akan letakkan logik 1 pada pin-pin yang berada pada lower half word yang lain. Sebabkan kita menggunakan GPIO B ODR, maka upper half word kita akan kita letakkan dengan logik kosong. Jadi untuk condition 1, LED D1 on, GPIO B ODR-nya adalah 0x 00 00 FFEF. Untuk condition 2 pada condition 2 ialah LED D2 on, D1 off, D3 dan D4 juga off. Maka kita akan letakkan logik kosong pada pin 5, logik 1 pada pin 4, logik 1 pada pin 8 dan logik 1 pada pin 9. Dan logik 1 pada pin-pin yang berada pada lower half word. Dan kita juga akan letakkan logik kosong pada pin-pin yang berada pada upper half word. Maka GPIO B ODR kita untuk turn on LED D2 ialah 0x 00 00 FFDF. Untuk condition LED D3 on, D1 akan turn off, D2 akan turn off dan D4 juga akan turn off. Jadi kita akan letakkan logik kosong pada pin 8, logik 1 pada pin 4, logik 1 pada pin 5 dan logik 1 pada pin 9. Dan kita akan letakkan logik 1 pada pin-pin yang lain pada lower half word. Dan kita akan letakkan logik kosong pada pin-pin yang berada pada upper half word. Jadi untuk condition LED D3 on, GPIO B ODR kita adalah 0x 00 00 FEFF. Dan yang terakhir, condition jika LED D4 on, maka D1, D2 dan D3 akan off. Jadi kita akan letakkan logik kosong pada pin 9, logik 1 pada pin 4, logik 1 pada pin 5 dan logik 1 pada pin 8. Kita juga akan letakkan logik 1 pada pin-pin yang berada pada lower half word dan logik kosong pada pin-pin yang berada pada upper half word. Jadi GPIO B ODR kita untuk LED D4 on adalah 0X 0000 FB FF. So untuk default condition pula, kita akan comparekan R5 dengan nilai masking yang kita dapat sebentar tadi, iaitu 0x 00000012. Jika equal LED off, maka kita akan jump ke LED off dan program akan execute coding yang ini saja. Untuk LED off, kita untuk LED off, kita akan letakkan logik 1 pada pin 4, pin 5, pin 8 dan pin 9. Dan kita juga akan letakkan logik 1 pada pin-pin yang berada pada lower half word. Kita akan letakkan logik kosong pada pin-pin yang berada pada upper half word. Jadi untuk GPIO-B ODR untuk turn off all LED, kita akan dapat nilai 0x 0000 FF FF. So mari kita lihat. Ini adalah apabila S2 ditekan, ke LED akan nyala satu persatu.
Okay guys, for the conclusion that I have learned from the lab 2 here is student able to complete the task successfully, and student also able to apply the theory from the class that we have gained and will learn to handle the task perfectly and successfully. And also student able to gain knowledge about the circuit of the STM32 Nucleo board there, and also able to know where to put the port correctly. So I think that is a good experience to do the circuit. Also, student will able to construct the circuit properly and gain the output like the here, like the part 1 and the part 2 the output to day 1. Okay, thank you.